This is 2012 FRQ number 2 in the calculator section. The R be the region of the first quadrant bounded by the x-axis and the graph of y equals natural log of x, so y equals natural log of x, y equals 5 minus x, y equals 5 minus x, as shown in the figure above. Find the area of R. So you really cannot do, well, you can if you want to, but if you want to keep it as dx, you cannot use these together. Dx goes this way, integrates this way, so you'll have to split it into two integrals. You're going to have to split it between the first one where the top minus the bottom, right, from 1 to this breakpoint, and then from this breakpoint to this next value, which is 2, 3, 4, 5. So at 5, this point to 5, and then of this function. All right. You could do dy, then you will also need to find that y value up here, and you can use right minus left. That's one function. So it really depends on you. I think since you have the calculator, it's really not that bad to just go ahead and use the calculator to help you. So first things first, I want to find out what that A point is. I want to find that intersection point, right? So I'm going to go to my graph, plug in natural log of x, plug in 5 minus x, and then before I press graph, I'm going to look at the window and make sure I match it as best as possible so I can see a lot of it. So I don't need the negatives, I need up to 5, so I'm going to go one more, so 6. For the y's, I don't need the negatives, so maybe a half, but maybe 2, and scale 1. All right, so this is my window, my scale. So press graph. Here's my natural log. Here's my 5x, and mine's a little skinnier than the other, but you can see. All right, there's the intersection. So second calc, intersect, get as close to it as possible. Where am I? Okay, enter, enter, enter. All right, that value, that x value is 3.6934414, comma, 1.3065586. That's my x and y value. Again, I know that the AP test says 3 decimal points, but because this is not my final answer, I'm using this to get my other answers. The more decimal places you keep, the better accuracy you have. All right, so what am I going to do? I'm going to cut it. I'm going to cut it right here. So part A says, find the area of R. R is equal to the integral between 1 to that point 3.693 blah, 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 of the top function natural log of x minus the bottom function 0. Plus, from that point 3.693 all the way to 5 of 5 minus x dx. All right, so first things first, we can go ahead and use it because it's already in the function here. We can go ahead and ask the calculator to calculate for us. So second calc, integral number 7, lower limit is 1, and then this upper limit is 3.6934484, enter, and voila, it naturally stops at the x-axis, so it's really nice. So my first area is 2.1322656. Okay, then the second one, second integral, goes from lower limit of 3.6914. Oh, it's already there. No, still not. It's not close enough. So 3.69. Oops, 6934484. Lower limit. Upper limit is 5. Enter. Whoops. Sorry. That did not work as well as I wanted it to because it is still under my natural log of x. So I don't think, let me see, does this work? I want y2 and my y2. Let's see, let me try one more time. If not, I'll just go back to math 9. 7, I want, y2, make sure you're at y2 because this is my second equation. 3.6934484, enter, 5, enter. There you go, it's the correct boundary there. All right, so that area is 0.853538854, and today 85353854. Oh, that's a lot of numbers. Okay, quit out of this. 2.1322656 plus 0.85353854. My area is a whopping 2.9858. So 2.986. All right. Remember 3 decimal places. Okay. All right. So now it says part B. Part B, R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis. So perpendicular to the x-axis is a square. So here's my square, kind of trying to be three-dimensional here. Right, but do not evaluate an expression involving one or more integrals that gives the volume of the solid. Sorry, that's the hot water heater. I'm not going to pause the video. Okay, so because of the fact that this is going to be dx, this is going to be two integrals as well. So the first half of the square is bounded by natural log of x, and the second half of the square is bounded by 5 minus x, right? So the base from here to here is natural log of x. The base from here to here is 5 minus x. So the volume is integral 0 to that 0.3.6934484 of natural log of x squared, because the area of each square is side squared. So side squared dx plus the other half, 3.6934484 to 5, the second side squared of my square. Okay, lovely. So that is part B. You don't have to solve first, you're done. Part C, the horizontal line y equals k divides r into two regions of equal area. All right, so you have this horizontal line, you don't know where it is, right? Really can't be like 0.5, it's probably around here. Because see, this is a lot smaller and this is a lot bigger, so somewhere there. Right, but do not solve an equation involving one or more integral whose solution gives you a value of k. So in this case, I would recommend now we go dy, because we have this y equals k. I can go dy and go 0 to whatever that k value is, and then the right function minus the left function, right? That would give me the area that I want right here. That's the half, okay? So what does that do? Well, first of all, we know the whole thing was 2.986. So half of 2.986 will give me, I am too lazy to do this, 986 divided by 2, 1.493. So 1.493, that means my area is going to equal to 1.493. Secondly, in order to do dy, I need to change my equations. So y equals natural log of x. If I take e of both sides, e to the y equals x. That's my left function. All right, y equals 5 minus x. If I add the x over and subtract the y, that's my right function. Okay, so the area is equal to, well, area is 1.493. That's half of the area that I wanted, right? It's equal to the integral 0 to k, because 0 to whatever k value it is, right function minus the left function, and then dy. I believe right, but do not solve. So that's it. That's my equation. Okay, that's it.